people now look into, okay, how can we actually measure performance for single page apps as well? And in order to do that, we first have to talk about one topic. There is a Cold War. And it's not this Cold War, obviously, that I want to talk about, but it's this Cold War. There's a Cold War between single page apps and multi-page apps. And it's going on for quite a while. And people are fighting with words and arguments, of course. And arguments go around, multi-page apps are way, way better when it comes to performance. No, single-page apps are way better when it comes to performance. And also when it comes to development and complexity and time to market and budget and essentially everything. So you have a lot of arguments going around. What is the better paradigm to do web applications, do web development? And obviously, since we're at the Web Performance Meetup, we want to focus on the performance part of this equation. And we want to focus on, okay, how can we even compare performance between multi-page apps and single-page apps? Before we dive deeper into metrics and tools and how to actually do this, let's do a quick recap. What are actually multi-page and single-page app? What differentiates it? And what are the different performance bottlenecks that we need to look out for? So starting off with multi-page apps. So this is your, I would say, standard web application paradigm. This is what browsers were built for back in the days. And this is essentially the first time that you land on the page, you will always have kind of a full page load, HTML, all the resources, JavaScript execution, and so on and so forth. And then when you go on navigating through the page from your home page to a product page, to a product listing page, for example, in an e-commerce shop, you will again and again have full page loads of these different pages. And all of these navigations between pages we call hard navigations because they trigger a full page load. And this is what multi-page apps are all about. These full page loads are essentially what is bottlenecking those applications most of the time. So what we need to look out for when we are facing hard navigations is mostly server response time. So how fast can your server respond with an HTML? That is kind of the complete markup that your users should see. Then your critical rendering path. So how many resources do need to be downloaded and how many round trips in order to actually render that page or construct that page that should be rendered for the user. And then, of course, rendering efficiency. So how many layouting steps and composition layer and painting does actually happen in the browser. So this is essentially what you concentrate on for multi-page apps. For single-page apps, this is essentially the paradigm that tries to get rid of these full page loads. You still have, when you navigate to the site, so clicking from Google to some online shop, you will still have a full page load because you need to load that application in a kind of standard browser-ish way. But every navigation after that can be a soft navigation, what we call it. And this is essentially not a full page load, but it is rendering the content that we want the user to see via JavaScript. So instead of doing the full reload HTML and critical resources and render stuff in the browser, we will change the DOM via JavaScript and then get all the things in that the users should see. Bottlenecks in those usually are, okay, we probably have some API responses that we need to fetch because let's say we are navigating from a home page to a product page. We need that product information that should be displayed for the user. So we are going to fetch that. Then, of course, we have our JavaScript rendering that will probably take some amount of time at least. And this will essentially change the document object model that the user sees. And then, of course, again, we have rendering efficiency because this changed DOM needs to be rendered to the user. So we, again, have layouting steps, composite layer, and paintings. So some things are similar, and some things are quite different, and bottlenecks are quite different. Sometimes we hear the argument, you don't really have to measure soft navigations because they're instant. The page is already loaded. You don't do a full page load. Why should you measure things like that? That is not true. You probably are very aware of that. API responses and rendering via JavaScript take up a lot time. And maybe even on kind of development machines like a new MacBook Pro with an awesome CPU, it is quite fast. but when you then start testing on lower-end devices, it becomes very apparent that you need to focus also on the bottlenecks that soft navigations impose. And also, I think one thing to keep in mind in this whole conversation between multi-page and single-page apps is browsers are built to do full page loads, and they are extremely well optimized for it. And doing the same thing via JavaScript has some benefits and has some of its own bottlenecks, but it's much harder for the browser vendors to optimize that. And this is why we need hard numbers to compare this, and we need hard numbers to understand where our bottlenecks actually lie. So let's talk about what tools we have on hand. And let's focus on hard navigations first, because there is an abundance of both metrics and tools in order to better understand our performance, better debug it, and help us improve it, essentially. I think most influential and most important at the moment are the core web vitals. So essentially user-perceived performance metrics that really tell you how good is the performance from a user perspective. And the great thing is you can measure them in the browser. You can track them via very cool real user monitoring tools or look at them in synthetic tests. You also have a lot of kind of drill down deeper level metrics like resource timing. So essentially the complete loading step of individual resources is broken down into steps and reported to you inside the browser in an API where you can actually understand, okay, how is that resource even loaded over the network? The same is true for the whole navigation. So speaking of full page loads, there are a lot of events and a lot of kind of tiny steps in that navigation. And it's really, really cool that we have metrics to deeper understand how that actually ties together and where our bottlenecks lie. So these are the metrics. And on the tool side, there is also really good news for hard navigations. We have kind of two different types of tools here. We have, on the one hand, we have real user monitoring tools. So tools that give you actually the performance that users experience on their on your page and give you access to the data in order to deeply analyze that. And then you also have synthetic test tools where you can actually run tests on specific pages and figure out what is wrong with it, do experiments, what probably helps with the issue, like Brian just chose with the INP and kind of simple fixes that he just tried out. And to kind of name a few tools, one of them, Chrome User Experience Report, short CRUX report. It gives you complete access to all your real user monitoring data. So essentially to the web vitals of your page. On a broad level, you can really drill down into specific page types and potentially some URLs. Yes, you can. But yeah, it kind of gives you a high-level overview. And you can even take this data and compare it with your peer group to understand, is my competitor actually faster than me, or am I faster? And what is my competitive advantage in page speed? You can also employ real user monitoring tools that give you really detailed access to all of this metrics and data on the left to really drill into and kind of optimize specific pages, for specific users that you can identify. And then you have things like web page test and Lighthouse, which are probably very well known in the audience here, where you can essentially see all the metrics on the left, but also have additional things like video analysis, and this yields additional metrics that cannot be measured in the browser directly. So that's looking pretty cool. But I would like to take it a bit more concrete and look at a timeline of a typical full page load and how these metrics help us to identify bottlenecks. So let's do that really quick. We are, again, still on the hard navigation side of things. And let's take a look at this timeline and metrics that happen during a full page load. So first of all, of course, everything starts with a navigation start. So this is when the user clicks on a link and the browser starts to download the HTML for the next page. Then at some point, you will receive the first byte for your HTML. You will probably start loading critical resources. This says CSS now because I have limited space and critical resource didn't fit. But you can think of essentially anything that is render blocking in this space. Then at some point, your HTML finishes downloading, your critical resources end up in the browser, maybe one round trip, maybe multiple round trips, maybe one resource, maybe 100 resources, I don't know. Then finally, we have something to show to the user. So first contentful paint happens. The user actually sees the first content on the page. That doesn't necessarily mean that the user sees the main content of the page. Maybe they only see kind of the navigation on top, for example. So we also have to look out for when does, for example, our main image starts downloading. We can also get that as a metric. We can see when the image finishes downloading. And then, at least in this view, lastly, we see the largest contentful paint. So the main core web vital for any navigation, to know when is the main component that the user is hopefully waiting for rendered to the user. And all of these metrics, they give us extremely good information about potential bottlenecks on our page. So what can we analyze from that? First of all, we can analyze time to first byte. So if this is bad, you probably need to look into your backend and see, why is my server doing so much stuff and taking so long to respond to the user? Maybe it's doing a lot of database calls and rendering HTML together, and maybe you can improve something on that side. Maybe the download of the HTML is particularly slow. Maybe it's just too large. We've seen, I think lately we've seen a few 17 or 25 megabyte HTMLs with a few large online shops in Germany. That was really interesting. But also, it could also be that your server is streaming HTML, and it's kind of streaming the HTML while it renders new parts of the page and streaming this to the user. This can also prolong your download time, and you have to look into that. Both of these are quite difficult to optimize, to be honest, but it gets a bit easier, I hope. Then you can look for your critical rendering paths. How many resources are we downloading? How many round trips does that take? So have we, for example, nested CSS, where we not download all the critical resources at once, but actually have to download one CSS, find another CSS inside, download that before we can actually do any meaningful DOM construction work in the browser? If that is the case, you will see it in the critical resource and critical path timings. Then we can understand how long does our rendering actually take. So when all the CSS and critical resources are loaded, how long does it actually take for the first contentful paint to happen? If you have a lot of CSS, probably a lot of unused CSS, as we see quite often, this can take quite a while. Or maybe you have really complex CSS selectors. And of course, you can drill into all of these bottlenecks with even more metrics that don't fit on the screen right now. But this even shows you, where should I look in order to improve my performance? And we're not close to the end here even. So next thing would be, if you finally reached your first contentful paint, we are focusing now on largest contentful paint. One thing that we see here as a potential bottleneck is load delay. So the time that it takes from the first byte of your HTML to arrive for your main image to load. There's really no excuse for there to be much time between those events, because in the best case, your main image should be discoverable by the preload scanner when it scans the first bytes of the HTML. Maybe you have preload tags or something like that in there, so that the browser is able to discover your main image as fast as possible. And this we see as load delay. Then, of course, we have also load time. You can see, for example, this will be long if your image is not optimized that good, if it just has too many bytes. But this can also be slow if there's a lot of network requests are happening at the same time, and you have network congestion. And then you might be able to think about, okay, is my image and my main image loaded with the right priority? Or do I maybe need priority hints in order to say, okay, this needs to be loaded with a high priority? So the browser actually knows, because otherwise the browser will load images with low priority, because they are just images. They don't block the rendering. We don't need them that fast. That's not true for the main image, because the user needs to see it. And then we have, lastly, render delay. So even when the image is there, is it straight away rendered to the user? Or is there a lot of rendering work either? Or maybe, and what we see even more, maybe you don't show your image right away, but have kind of JavaScript lazy loading or something in place, which then only kind of renders the image into the DOM at a later stage. So when your LCP is depending on JavaScript, you will definitely see it in one of those metrics, either in the load delay, because even your image source is not even handed to the browser yet, or in the render delay because the image might be downloaded, but not actually in the DOM and ready to render. There was a lot. And I wanted to show you this because I wanted to emphasize how much we understand about hard navigations and how great the metrics are that we already have in order to improve it. Now, I've even color-coded which APIs give you which metrics. So we have navigation timings, resource timings, and web vitals. Let's now take a look at the same picture for soft navigations. How are things looking there? Well, this is not fully animated, so wait for it. We don't have web vitals. Core web vitals just don't work for soft navigations. You don't get any metrics, at least not any meaningful metrics. You can get some metrics sometimes, but they are more confusing than helpful, really. So you don't have core web vitals, essentially. They don't even know about soft navigations. They think you're still on the same page. You don't have, of course, you don't have navigation timings because those are timings about full page loads. You simply don't have them. You still have resource timings. That is good. It's just a bit of a struggle to pinpoint which resource belongs to which soft navigation because from a browser perspective, they all just happen while you're on the page. On the tool side, it's similar. You don't have a crux report. At least you still have a crux report if you have a single page app. But it doesn't include soft navigations. It just includes hard navigations, which is an issue because now your page only has hard navigations for users that visit the page kind of through, not for the first time, but kind of through a hard load, which does a lot more things than the usual hard navigation. For example, usually if they come from Google or something, they need to do TLS handshake. They need to first of all, get your domain to an IP address and a lot of stuff on network level that hurts your performance, which is the reason why most single-page apps in the Chrome user experience report, when you compare them to multi-page apps, they look way, way slower because the faster soft navigations are not factored in at all. So crux report, yikes, doesn't help you that much. And especially you can't really compare it to your multi-page app competitor. Run tools, yeah, there are ways to track soft navigations. Of course there are. And we also will get into details on how to best do that. But you have to, in almost all cases, have to do that manually with custom code. So it's not just throw a run tool in there and then get all the information that you need for optimization. Web page tests on Lighthouse, they are built for hard navigations. They do support soft navigations and interactions. Brian also showed that Lighthouse has this interactive mode. So you can get some information, but of course you will be missing a lot of metrics, and it's much harder to do that. For Lighthouse, even you need probably actual code instead of just clicking buttons in the browser. And also for web page tests, you need scripted runs and take care of what is actually measured in these soft navigations and when things are measured. So I would say let's do for soft navigations now the same thing that we've done for hard navigations and look at a timeline of a soft navigation and try to figure out what bottlenecks could we identify and how helpful is that. So timeline time again. So what metrics do we actually have? We've learned we have resource timings. That's good because our soft navigations, they have API calls and they load probably new images when we navigate to a product, for example. So let's put those in there. We have an API start, API end. We have an image load and an image end. Now that is somehow useful already, of course, but we are missing some metrics that we would actually be interested in to fully understand what is going on and where potential bottlenecks are. We, for example, definitely need a navigation start because otherwise we know how long our API takes and we know how long our image takes to load, but we don't know where's actually the start of all this. Then we also need essentially the time where our framework starts to mess with the DOM. So to actually update the DOM with our new product data, for example. Because otherwise we don't even know when the browser would start rendering, which means we couldn't analyze render delays at all. Then we need something like an FCP, really, and we definitely need something like an LCP. So essentially, core web vitals would be really awesome. Those are in a generic case, those metrics in red are not available. But we will now look into examples of how can we actually, with custom code at least, or with some programming, get to those metrics and start analyzing our soft navigations. First thing is, when we have this, of course, we need to talk about bottlenecks first. So when we have navigation start and API start, we have something like a processing delay until we actually start fetching the product data finally. Then we have something like the API response. Of course, APIs take some time. Then we have some processing. This is usually in your single page app framework, where it has the JSON information of the product, but it needs to convert it into a document object model that then updates the actual DOM in the browser. And of course, we have render delay. We need render steps. Again, we need to look into, is our CSS well optimized? How much CSS do we kind of inject on soft navigations? Because then the browser needs to do work all over again. Again, we have something like a load delay. This time, we are not waiting for the HTML first byte, but we are waiting for the API response. Not the API response first byte, because JavaScript doesn't do anything streaming with API responses. I think we are pretty happy that it's the case, because that would make things really, really complicated if we would do that. Then we have load time again. This is image optimization, you know that, and render delay, which is essentially similar to hard navigations. Right. So if we would have all these metrics, we could actually break down the performance. Maybe for some of the intermediate parts, there are less performance metrics to then drill deeper. So that could be an issue. But we will look at some ways to, or some APIs that we have in order to improve that. So let's focus on the metrics that are missing. Let's focus first on navigation start. It's actually not that easy to figure out when a soft navigation starts. One option that I've outlined for you here would be the history API. So the history API essentially keeps track of the URL for you at the top of your browser. And when you do a soft navigation, usually you change that URL. Yeah, that's a good idea, because then users can also use the backward and forward buttons, and they are really used to that, and they want to use that. So you're essentially using the history API for that. What you can obviously do is override the history API, so kind of store the original push state function, then override it with your own, and whenever the push state thing is called, you kind of infer it probably was a soft navigation start. And then you should do the same for pop state, because when the user navigates back, that is soft navigation again, right? And your single page app framework will likely do the same, because it also needs to then jump back to another page. This is cool because it's generic, but it's also not super cool because it overrides native APIs, and nobody really likes code like that. And things can go wrong if you do things like that in production. So another option is something where you just do custom code. So you probably know when a soft navigation happens, or at least your single page app framework knows. And there are cool APIs to do custom timers. And one of those APIs is Performance.mark. So it's a native API in the browser. All the browsers actually support it. I thought that I added browser compatibility at the top. No.
It's gone. It cannot load.
I opened the wrong presentation. I had one where the code is larger. But, yeah, this is the one version with bigger code, and it also has browser compatibility, but only the 3 browsers that most people care about. Sorry if you're using other browsers. Right, like Edge, which is essentially Chrome, so don't worry. Right, so you can use performance mark to set marks when things happen. For example, if you know there is a route change that begins now, a soft navigation, then you just set a mark, and the browser takes care of just saving that point in time for you. And this will come in handy on the next slide, actually. So let's look at the next metric, which is I changed the DOM metric, which essentially you can only do via custom code, or your single page app framework might even do it for you. And this is if you know when you've rendered things and you're kind of transferring that to the DOM of the browser, and now the browser kind of has the opportunity or the burden or whatever to render that, then you can actually use another cool custom performance metric API, which is performance.measure. So you can give it a name, what it should measure, so what the timing should be named that you measure, and then you can give it a performance mark, and it will just kind of record the time from that performance mark until now. And now you have essentially, in this case, the JS route change to render. This is actually what Next.js will do for you. So it will give you some kind of information about performance events in your single page app. It also gives you information about your rehydration on full page loads, but also on soft navigations, it will give you things like these. The way that you look out for these events, because soft navigations can happen at any time and you want to be informed when that happens, is performance observers. We've seen that with Brian already today. So that is cool. I don't have to explain everything about them. So essentially, you register a performance observer, and you have some callback that is called when a new performance entry is inserted. And you then say, okay, the performance observer should observe, in this case, it's type measure. It should also give you the buffered things when you are late to registering your observers. And then when you're in there and you get these measures, you can just match for the name. And if you have it, the start time will give you your navigation start metric. And the duration will give you the point in time where the DOM changed. And then you have essentially the two metrics that you're looking for. Next one up is FCP. And I actually bundled this with the LCP. And apparently I didn't care to animate that anymore. Right. So for FCP and LCP, things are a bit more complicated because it's not a point in time in your framework where you do stuff in JavaScript, where you can just set a mark, but it's things that the browser does. The browser renders things to the user, and you can't really measure that as an exact time in JavaScript. And because that is the case, we have something that is called element timing API. And with that, you can actually add HTML attributes to your markup. So if you have an image, you can say element timing and then give it an identifier. If you have a text element, you can also give it element timing and the text. And then again, you can use performance observers to listen to the point in time where these render. And then it's essentially the same code. You filter for the big image identifier here. And then you will get the image timing start time, which is your LCP because it's the point in time where the image rendered. Most of the time, at least, if you are hosting your images on a cross-site domain, so not on your own domain, like, for example, Shopify shops do, you need to set navigation timing allow header, because otherwise, out of security reasons, again, Chrome won't tell you when the image rendered, only when it finished downloading. Because apparently you can infer evil things like Jörn is, for example, Facebook user. Yeah, that is it. That is essentially how you can polyfill, I would say, the metrics that we get for free for hard navigation and that we get in a generic way. So how do we feel about that? What do we think about these options? So on the positive side, we have a full breakdown of our soft navigations, more or less at least. And it's achievable to have that in the data, and with some effort, you can then start analyzing. It works for monitoring performance, so you can actually see, does my soft navigation performance improve, or does it degrade when I do a deployment of my application? And it works also for debugging and improving, because you can identify bottlenecks that you can later on hopefully solve. It doesn't work that well for kind of ease of use. You still need a lot of custom code in order to program that. And it's probably code that you need to do custom for at least every page type, because you need to identify the main element for the user. You need to identify, well, the other things are more or less, yeah, the other things probably more or less work, but you definitely need to identify the elements that you're interested in on the page. And then also, you cannot still compare this. You cannot compare to a multi-page app. Even if you would say, okay, let's try out for a month to do just hard navigations on our new fancy single-page app, you don't have any metrics to compare whether this is better. You can, of course, look at a web page test example and see, okay, yeah, maybe not. But you can't have real user monitoring data. So that is a pity. So what we actually want, this is my conclusion at least, is we want native timers for soft navigations. We want core web vitals for soft navigations, and we want to be able to compare these between different paradigms and how we decide to build our applications. And there is good news. There recently, I think it was in February, a Web Vitals for soft navigation experiment started. So Google actually gives you now the opportunity to track or to see soft navigation timings. So navigation start, you don't have to override the history API anymore. You can actually look into the performance timings, and you have a new entry type for that, which is soft navigation. You can look at the start time, for example, on that and have your navigation start. Of course, you wouldn't do it like that. You would do it with performance observers again, because they keep happening over and over. And also, even better news, Web Vitals work. You get Web Vitals as performance entries like you do on hard navigations. That is awesome. You just have to give it a include soft navigation observations true. That is the point in time where I'm really glad that I switched to the bigger code version of the talk. So this is also not only true for LCP, but it works for all the Web Vitals. It works for INP. That is awesome. It works for CLS. It works for FCP. So you get all the timers. The not so good part of this is an origin trial, and it's not called an experiment for nothing. So Chrome is currently doing this as a limited origin trial. So if you have an application, you can activate that origin trial with a header in your HTML, or you can do it in your local browser for any page that you visit. So you can actually look at this data, but you can't track it across all pages if they don't opt into the origin trial. And also, Chrome is looking for feedback on this. This is mostly, I think, developed by Joa Weiss, who's deeply interested and involved in this topic. And they are looking for a lot of feedback. So while this is running, and I think it will end in a few months time, maybe even in a few weeks, try and get your hand on this and try and look at a few performance examples. It may still be a little bit rough around the edges. Maybe not every soft navigation is detected, because those are heuristics in order to actually detect what is the soft navigation and what is the kind of next paint and next largest contentful paint after that soft navigation, because it's probably complicated if you look into the details. So it doesn't look like this is landing in the core Web Vital main thing soon-ish, and it's probably not going to land in Chrome user experience report soon, because we know for a fact that they at least have a 6-month kind of notice period when they change something this drastic to Chrome user experience report. So they would inform us that this is going to happen probably even a year in advance, like they do with INP at the moment. But we would really wish to have it in there. But until then, you can actually play with it. You can track all the data. You can look at it in your local devices on kind of different pages that you don't own. And this is essentially what we've done. And I want to end the talk with this, because we were also interested, and we actually own a view-based single-page application, which is our corporate website. We did an A/B test with 2 groups. One group had soft navigations enabled as a standard with our Vue.js page, and one had hard navigations, where I just got some JavaScript in there which blocked the soft navigations and did navigation. I didn't want to wait for the front-end team to implement it. But we have some data on that. because finally we have web vitals that we can compare. And this might come as a surprise to some at least. This is only our one case, and it's a pretty simple page, but I was actually astonished to see that. The blue one is the hard navigations, and the red one is the soft navigations. And I've looked at a few different percentiles from that performance distribution. So median is your midpoint value, your average user, your median user, not your average user. And then you also have 25th and 75th percentile. And it's actually faster with hand navigations. That is some food for thought, I would guess, and probably also a good starter for some discussions afterwards.
Which metric is
this is LCP. Sorry, yeah, I should have put that in there. We are fortunate enough to have a real user monitoring tool on our hands that we are using for that. And yeah, we track this across all our user base. But that's it. Thank you. Any questions or hateful commentary? Stefan.
Just one question. You have some obsession with David Hasselhoff.
Yeah, exactly. I'm not even sure if I need to repeat the question for the video, but anyway, so we seem to have an obsession with David Hasselhoff. He's on a poster, shirtless over there, and I'm not sure who of you has seen the real kind of life-size figure of it in the hallway. Yeah, this is courtesy of our colleague Wolle, who's professor at the University of Oldenburg right now, and not here at the moment. Yeah, and he's really into David Hasselhoff. A few colleagues as well. Yeah, another question there.
Yeah, I have a little addition.
Yes.
Regarding meta frameworks, which are actually both single page and multi-page in one. And since they have a lot of soft navigations, the next team exposes, since I don't know how long, web vitals book that allows you to report these web vitals for soft navigations. As far as I know, the Svelte kit is, also has this, and the next team is working on it. I'm not 100% sure on that. But if you want to have a really easy way to get these web vitals for soft navigation, you can check out the Next.js docs, and they expose this use core web vitals for this case.
Ah, very cool. There was just for the video, there was a comment about meta frameworks like Next that are exposing hooks for core web vitals that they probably implemented themselves in the framework. And this makes it really easy to track this information and start to optimize soft navigations. I really like that. The only thing that I see with it, it's probably hard to compare those to the really core Chrome Web Vital metrics, because metrics, if they're implemented differently and especially by different vendors, they tend to kind of be hard to compare. So that would be even better when we finally get kind of the full support for Web Vitals natively. But still, this is awesome to debug performance and to improve it in the end, and even to monitor. More questions? Yeah, Stefan.
I'm not sure if this is possible, but are you also trying to amend code in SpeedKit to inject code to measure this?
Yeah, there's an awesome question. The question was whether we with SpeedKit try and inject code in order to be able to measure soft navigations. And yes, actually we do. We have a lot of customers who are also using soft navigations and single-page app frameworks. And we not only want to help them improve their hard navigations, which we can kind of easily do with SpeedKit, but also help them on soft navigations, especially by caching API responses and also making the application a bit more efficient. And for that, we, for example, we have cases where we inject element timing API things. which we can, for example, do, since we are on the outside, we can't change their code base. What we do is sometimes that we have mutation observers, which then, when the DOM is manipulated, inject those metrics, which in and of itself, of course, also has a performance impact. So kind of measuring usually has an impact in itself. So we sometimes do that, but we usually, because with SpeedKit, we focus on delivering parts of the application over the network as efficiently as possible. Most of the time, we can actually rely on the actual navigation, the actual resource timings, because with us, hopefully the image will be loaded earlier and faster, and whether it also it will probably not render much faster with SpeedKit, but it will also not render any less fast because we don't change anything about the layouting and what is important for the rendering. So we can essentially infer our improvement with SpeedKit by only looking at kind of how resources load in the browser, more or less, at least in most of the times.
I know you're also working on like measuring where the time is spent in SpeedKit, and probably you could also then give users hints where time is spent in JavaScript code. Right.
So the question was whether we can also give hints on where our bottlenecks are, especially in JavaScript code, when it comes to improving soft navigation. So we've built a full real user monitoring system. So we are tracking a lot of metrics and making sure you can easily kind of get your learnings out of them. And one really difficult topic is JavaScript profiling in real user monitoring, because there are not a lot of metrics, no matter whether it's hard or soft navigations. You have something like long tasks, but there are also attribution. You can track long tasks, but attribution of the long task to which script is responsible for that long task is really poor. People on the Chrome end especially are working on that, but it's hard to expose information without ruining privacy and security. So JavaScript is a bit hard to do in the wild, and for a lot of JavaScript related debugging, the browser and synthetic testing is probably your best fallback.